Alright, we're going to extend on the Pythagorean theorem in 7.2. We're going to talk about Pythagorean triples and the converse of the Pythagorean theorem. Alright, you previously learned that when two sides of a right triangle are known, the third side can be found using the Pythagorean theorem. Okay, remember that the Pythagorean theorem is c squared equals a squared plus b squared, where c represents the hypotenuse of a right triangle, and a and b represent the two legs of a right triangle. Any group of three positive integers, a, b, and c, such that c squared equals a squared plus b squared, is known as a Pythagorean triple. So in other words, every time you've taken a right triangle and taken two sides and found the third number, the two sides they already gave you, and the third number you found, those three sides of that right triangle are three numbers that work for this equation. So now the only difference between those three numbers and a Pythagorean triple is that for a Pythagorean triple they have to be positive integers. So we're looking for whole numbers basically, because you don't have to worry too much about negatives when you're actually solving the right triangles. Side links cannot be negative, but they got to be whole numbers. They got to be integers. They can't be decimals and fractions and things. So if I'm looking back at the notes from 7.1 and looking at those examples, okay, this triangle would not be a good example of a Pythagorean triple, because while these are positive integers, this is not a positive integer because it's not a whole number. This would not be a good example of a Pythagorean triple because, again, not all positive integers. This is not a whole number. However, example 3 would be a Pythagorean triple. 8, 6, and 10. Those three numbers are all positive integers. And so 6, 8, 10 would be a Pythagorean triple. Right here, 5, 5, and 5 squared to 2, not a Pythagorean triple because this number is not a positive integer. For it to be a Pythagorean triple, all three numbers have to be positive integers. 4, 8, and 8.9, not a Pythagorean triple. So they got to all three be positive integers. Alright, so is 3, 4, 5 a Pythagorean triple? Well, what we would do, first off, you'd look at the numbers. Are they all positive integers? Yes, they're all positive integers, so that checks out. So the other thing you got to check is, does it work for the Pythagorean theorem? Now remember, in a right triangle, the hypotenuse is always the longest side. And remember in the Pythagorean theorem that c is always the hypotenuse. So when you look at your three numbers and we plug them into Pythagorean's theorem to see if it works, make sure you always put the largest number in for c. So the largest number here is 5. So we make sure we put 5 in for c. And then 3 and 4 can go in for a or b, and it does not matter which one's which. Okay, well if we work this out, 5 squared is 25, 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So that works. The a squared plus b squared came out equal to the c squared. So these numbers do work for the Pythagorean theorem. They are positive integers. So yes, 3, 4, 5 is a Pythagorean triple. And this is possibly the most commonly used Pythagorean triple. So let's name the most common Pythagorean triples. We got 3, 4, 5, which we just discovered, 8, 15, 17, 5, 12, 13, 7, 24, and 25. Now there are other Pythagorean triples, but these are some of the most commonly used ones. And with Pythagorean triples, any multiple of these three numbers would work as well. So not only does 3, 4, 5 work in the Pythagorean theorem, not only could 3, 4, 5 be sides of a right triangle, but any multiple of those. So if I multiplied all of these by 2, so 6, 8, and 10. Now that one might sound familiar. Remember our problem earlier in 7.1, this triangle had side lengths of 6, 8, and 10. If you have memorized your most common Pythagorean triples, you can save yourself all this time and effort, because when I look at this right triangle and I see sides of 6 and 8, I already know that that side's going to be 10 because that's one of the most commonly used Pythagorean triple. I've memorized that, and so when I see 6 and 8, I know instantly that that hypotenuse is going to be 10, and I don't have to do any work to figure it out. So we can memorize these Pythagorean triples and then just keep a lookout for multiples of these numbers as well. So 3 times these numbers, 9, 12, and 15, would be a Pythagorean triple. Okay, any multiple on any of these are the most common ones, so try to memorize these if you can, and that will help you shortcut the process on doing some of these Pythagorean theorem problems. Alright, recall that given 3 sides, a triangle can be formed only if the sum of the two shorter sides is greater than the longest side. In every triangle, any kind of triangle, the sum of the two shortest sides has to be greater than the longest side. If I give you 3 segments and the longest one is longer than the sum of the 2 shorter ones, then you are not able to make a triangle with that. It's impossible. So, in example 2, which of the following can be lengths of a triangle? So we're just reviewing here. So I take the 2 smaller ones and add them together. 4 and 5 add up to 9. Is that sum greater than the longest side? Yes, so you could make a triangle with this one. So it says, which of the following can be lengths of a triangle? A can be. Right here, 4 plus 5 is 9. That's not greater than the longest side. It's equal to it. That doesn't work. 4 plus 5 is 9. That's not greater than 10. It's less than 10. That will not work. Only A gives you 3 numbers that could possibly be the lengths of a triangle. Alright, recall that one way to classify triangles is by angles. A triangle can be acute, obtuse, or right. Remember, every triangle has 2 acute angles. It's the third angle that determines what type of triangle it is. So, if it's going to be a right triangle, it only has to have 1 right angle. If it's going to be obtuse, it only has to have 1 obtuse angle. However, because every triangle has 2 acute angles, the third angle would always also have to be acute, so you'd have to have all 3 angles acute to make it an acute triangle. Well, if a triangle can be formed, you can determine the types of triangles formed by comparing the square of the longest side, c squared, to the sum of the squares of the shorter sides. So we're taking the c squared and the a squared plus b squared from the Pythagorean theorem, and we're comparing them. Well, we just learned earlier that the Pythagorean theorem works for right triangles, specifically. So the Pythagorean theorem shows that the c squared is equal to a squared plus b squared. So anytime you take 3 segments that are supposed to be the lengths of a triangle, if the c squared is equal to a squared plus b squared, that means it has to be a right triangle. Okay, it'll be an acute triangle when c squared is less than a squared plus b squared. And it will be an obtuse triangle if c squared is greater than a squared plus b squared. Well, let's just think about this for just a second and try to understand this concept. If these are 2 sides of a triangle, and you can just imagine in your mind connecting these to make that third side. I'm going to zoom out just a little bit. Maybe I'm not. The zoom button's not working. Alright, imagine in your mind connecting these 2 to create that third side. This right now is a right triangle. So in this particular case, understanding Pythagorean's theorem, the c squared is equal to a squared plus b squared. Well, if I make it an acute triangle, then that means this right angle needs to become acute. So I got to make it smaller. When I make it smaller, what happens to the c? The side that was c now gets smaller, right? So now the c squared is going to be less than a squared plus b squared when it's an acute triangle. So because this angle getting smaller makes this third side smaller, that c squared is now smaller than a squared plus b squared. Get it back to a right triangle. And now the c squared is equal to a squared plus b squared. Well, if I want an obtuse triangle, then that right angle needs to get bigger so it's greater than 90. But as I make that angle bigger to make an obtuse triangle, what happens to c? It gets bigger. So now the c squared is going to be greater than a squared plus b squared. Alright, hopefully that made sense. Let's look at example 8. Determine if a triangle can be formed, and if so, classify it. So we're going to say whether it's acute, obtuse, or right. So first we got to check and make sure it can make a triangle. So we need to add the two smallest sides together. 5 and 4 are the two smallest. 5 and 4 add up to 9. That is not greater than 12. The sum of the two smallest has to be greater than the longest. So you cannot even make a triangle here. And if it's not a triangle, you can't classify what type of triangle. It's not a triangle. It's not any of them. Alright, so let's look at the next one. 6 and 7 are the two smallest. That adds up to 13. That sum is greater than 8, so we can make a triangle out of this. So now let's check and see what type of triangle. So I'm going to find out what c squared is, and I'm going to find out what a squared plus b squared is, and then I'll compare them. So make sure c is always the longest side. So 6, 7, 8, 8's the longest. Make sure that goes in for c. And then the 6 and 7 can go in for a or b, and it does not matter which one's which. Alright, well, 8 squared is 64. 6 squared plus 7 squared is 85. Well, c squared is less than a squared plus b squared. 64 is less than 85. And anytime the c squared is less than a squared plus b squared, it's an acute triangle. Let's try the next one. So on C, let's add the two smallest together. Now first off, most of y'all probably don't know immediately what the square root of 10 is. And so comparing the numbers and knowing which one's the longest side might be challenging for you. You can type square root of 10 in the calculator, and you'll see that it's approximately 3.16. So it is bigger than 1 and 3. So this is our longest side. Now if I add 1 and 3 together, that's a total of 4. Is that sum of the two shortest greater than the longest? Yes, 4 is bigger than approximately 3.16. So we can make a triangle. Sum of the two shortest is greater than the longest. Now we want to check out what c squared is and check out what a squared plus b squared is and compare the two. Remember, the longest side always goes in for c. Now, we found out what the approximate value of square root of 10 was because we needed to compare it and see which one is largest. But make sure you don't use this number when we're plugging into the formula. We don't want to adjust the values at all, because if you are rounding using a rounded number, your answer is going to come out off. Remember, for it to be a right triangle, the c squared has to be exactly equal to a squared plus b squared. So if we use a rounded number, something that was supposed to be equal will no longer be equal anymore. So we can't use rounded numbers. We have to make sure we use the exact numbers. So when I proceed from here, I make sure I use that square root of 10 in for c. 1 and 3 will be your a and b. Doesn't matter which one's which. Okay, square root of 10 is 10. 1 squared is 1. 3 squared is 9. 1 plus 9 is 10. So those come out equal. So if we had used that rounded number, we would have gotten the wrong answer. Now, when c squared is equal to a squared plus b squared, remember that means it's a right triangle. So this is a right triangle. Okay, let's try D. Now right here, these are all radicals, so you might need to check and see what the values are. Now a couple of these are easy though. What's the square root of 9? It's 3. Square root of 16 is 4. Now the square root of 27 doesn't come out exact, so we might want to plug that one in. Square root of 27 is approximately 5.2. Approximately. So this is the longest side. If I take the two shortest, 3 and 4, and add those together, we get 7, and that sum is greater than the longest side. So we are able to make a triangle, so we just got to figure out what type of triangle. So we check out what c squared is, check out what a squared plus b squared is, and we'll compare them. So the longest side always has to go in for C. 3, 4, 5.2, this is longest. But again, don't use the rounded number. Make sure you use the exact number when you plug it in. Now, these are not rounded. They came out exact. Now, if you want to put in square root of 9, you can. There's nothing wrong with it. But 3 is the exact same thing. That's not a rounded number. Alright, so the square root of 27 squared is 27. Square and square root just cancel each other out. And then 3 squared plus 4 squared is 25. 9 plus 16 is 25. And so when I compare them, the c squared is greater than the a squared plus b squared. 27 is greater than 25. And anytime the c squared is greater than a squared plus b squared, that means it's an obtuse triangle.